We're going to continue on making these brass pieces for the lens stabilization project, the instrument Spirou. So I've got the part loaded up and I've made some tool paths. I got to give a big shout out to MCAM Northwest, and I'll leave a link in the description of the video. They're our MasterCam provider, and their streaming teacher, all their online training courses and whatnot, second to none. I wouldn't be where I'm at right now without MCAM Northwest. So big shout out to those guys. So yeah, now that I've got most of the programming done for this side, as far as just the cutouts, I haven't done any of the holes yet. We'll go ahead and burn this to a disc and get it transferred over to the CNC and go from there. Here you can see I've loaded up a tool. This is a 3/16 4-flute end mill, and got a little device here to check for run out on the tool, and I'll spin this guy around and you can kind of see what the run out is. Where this is a fussy part, so we're trying to get the run out as close to 0 as possible. Here's another flute. There's another flute. Yep. Probably about 2/10,000ths of an inch of run out, so we can live with that. It's not bad for an ER15 collet. Okay, so we got the piece set up in the CNC. Got 2 lathe chucks, one on top of another. A little wonky, but it's the best way I could figure to hold this piece well. I've got a little tape in there to protect the surfaces. And really the first thing that I do is just verify that that this thing is sitting flat in there, and it is. It's well within half a thou. And the next thing we'll do is use this indicator, sweep around the outside, and that'll establish our X and Y centers. Okay, and then sweep the outside, and I'm dead nuts on, well within a half thou anyway. So then all we gotta do is run this program, and it will turn X and Y to 0. Okay, we're only going to use about 5 tools in this setup, so the 1/2-inch end mill is the first one. Here's how I set tool height. Use a tool setter, balances the heights of all the tools. I'll go to my fine adjustment. Set that at 0. And then here I've got tool setup, and here it says Z tool length, so I just hit that. And we're set. Puts a value in Z, and now when I set other tools, they'll all be the same. Alright, to set Z height now, I need to touch off on the material. There's other ways to do it where you don't touch the material, but in this case, this entire front face of this thing is going to get machined off. So this material up here will be gone. I know it's flat. I've already run my indicator across that. So I'm just going to touch this off. I'm going to come down by 1/10,000th increments until I just barely get a shine going. There it is. just a light touch, 1/10,000 increments. And now we go ahead and set the Z height. Alright, so we got our programming done in MasterCam, and we're going to go ahead and simulate this, this run. So all we do is hit play. You see the 1/2 inch going in and getting rid of most of the material, and then we load up the 3/16. We come in and kind of rough, and then there is a final spring pass. Only takes off a 1/2 thou. And even with that spring pass, we should be 1 thou big. That'll give me room for an adjustment. We'll come in and we'll measure across these flat faces, front and back, and take a real accurate measurement and make an adjustment, and that should bring us right to tolerance. Alright, so we got that part all cut out. Now we got to measure across those flat surfaces. And, you know, calipers are good for maybe 1 thou. Maybe not very repeatable, but you can get pretty close to 1 thou of accuracy on a good set of calipers and good skills. What we're going to use is a micrometer. This one's a digital micrometer, and it's good for half a 10,000th. So I've gone ahead and used the provided little block of this little gauge block, and we use that to actually calibrate and set to 0. And according to my drawing, the number that we're shooting for nominally will be 1 inch, 739 8/10,000ths of an inch. So we'll see what we got. We should be 1 thou bigger than that if everything works out all right, and it usually doesn't. Okay, so the number we got was 1.7416, and what we were shooting for was 1.7398 plus 1 thou, because we left half thou on each side. That brings us to 1.7408. The difference is 8/10,000ths of an inch. So we divide that by 2 because we've got two different sides we're measuring across. Come up with 4/10,000ths of an inch, and that's the adjustment I'm going to have to make to the end mill diameter. Okay, so I changed the stock to leave to 0. It was at half a thou. Changed that to 0, and I adjusted the diameter of the end mill from 0.187 to 1.866. That gives us our 4/10 thou that we need a little more cut. So we'll run just that spring pass, which you can see here. We'll run that spring pass on each side once again, and then we'll take another measurement and see where we're at. Cross our fingers. Okay. I think we're good. Okay, so this hole right here is called out at 18 millimeters, but it's plus 0.1, plus 0.2, so it's actually 0.71456 is what they're shooting for, really. So I programmed that. Now that we've got the adjustments made from this this flat one that's easy to measure, so this is pretty loose for what we're doing. So went out and cut that, and now what we'll do is we'll pass some gauge pins. This is 7140, and this is 0.715. So this one should fit. This one should not fit. And so this is my go, no go. All right, so 714. Just goes. And 715. No matter what I do, it will not go. Okay, so now the only thing that's left is to come in and clean up these edges. Internal ID, external OD here. Bring everything down to the right height, and we'll be ready to drill some holes. And I've got the tap, or the tap drill and the tap set up for these 2 millimeter holes on the inside. So we'll do those. Okay, so we got all the surfaces cleaned up, including some of these edge breaks. And now we're going to go ahead and drill some holes. We'll start with the little ones that are up inside here. Okay, so we had to swap out the drill and the tap for M3, which is the rest of the holes. So now we got to just reset tool heights. There we go. All right, we got the tool set up, and now we'll just press go. finished part. At least for this side. We have some more work to do on the other side. But yeah, gives you a good look at close up what we got going on. The chamfers around the edges, edge breaks, and the holes are only tapped about 1/8 thou deep. I do that so I don't run the risk of breaking a tap. I'll finish those off by hand. It's much safer that way, especially with the 2mm hole. 3 not so much, but 2mm, that's an awfully fine tap. So there's a good look at what goes into making one of these tiny little parts. We're about halfway, maybe 2/3 of the way done. We still have a bunch of work to do on this side, which is some weird stuff with a custom-made end mill. Yeah. So we still have the risk of destroying this whole thing, days of work into it, but we'll do our best not to. So I run all my programs kind of one operation at a time. There's a couple reasons why I do that. One is because my old CNC machine just doesn't do so well with multiple ops. It has to do with the air compressor kicking on, the air blast that goes along with the tool change, and that causes the air compressor to kick on. When the compressor then kicks on, it's just about the same time the spindle speeds up, and that blows breakers, has all kinds of electrical problems. So that's one reason why I don't do that. Another reason why I run single steps at a time is because I really have to proof this thing out as I go. Every part I make is a one-off custom. So I'm setting up all the diameters of the tools so I can get my measurements just right. And yeah, just kind of the way we do it when we're prototyping. I don't do anything where I do large runs of any parts. So that's just kind of the way I do it. It takes longer, but the results speak for themselves.